What's up? आवाज आ रही है? You should see me right now as well. And that's my chair in the view that I've just pushed out. How you all doing? Electrochemistry, Faraday's laws and electrolytic cells. यही करेंगे हम आज. Yeah. Apologies for that tiny glitch. You're able to hear me and see me clearly, right? All that's good out of the way. Hold on, let me figure out the chat. Hey, Rek, Arman, thank you for coming so early. Agam, everybody here, मेरी आवाज साफ आ रही है? Just give me a heads up and we'll start. All right, let's get started right away. So, homework questions. So, what I'm going to do is I'm going to take a screenshot of everybody who's giving me homeworks and I'll put that out here. This chap is awesome. He's got a photo of, he or she's got a photo of Radha Krishna right there, I think, right? It's a very tiny photo, but it looks like Lord Krishna. He's got the flute there and all of that. Yeah, pretty sweet. Anyway, so this person is saying science. What's this person's name? Hold on. Science BYG. This person saying question 1 is A, question 2 is C. Question 1 has more than one correct answer. I'm going to dive right into it. Why waste your time, right? Homework question say concentration cells के बारे में. आज के session में we're going to talk about electrolytic cells and also Faraday's laws. Yeah, the big one. We're going to do that. उस पे almost हमेशा JEE में सवाल आते ही हैं. Like every session of JEE, every alternate session of JEE has a question on this, either on this or on Nernst equation. यही सारे सवाल आते हैं. खैर, what's up? Let's get started. Rek, Arman, Agam, AK, Rek again. It's okay. चलता है. अभी कर लो. That's what we're here for. In the concentration cell, you've got something over here. You've got something over here. ये है buffer. Quick hint. ये है buffer. Value of cell potential will depend on which of these. Okay. Science person said it's only A, but I think the answer can have more than one answer that is option that is correct. And I don't know if A is correct or not. We'll see. We'll quickly see. But what do you think can happen here? Any idea how to solve this question, or should I give you a hint? Okay. देखो temperature पर definitely depend करेगा, right? There's no doubt there. Temperature is definitely one of the options. Okay, so B has to be one of the options. What about the others? Think about it. Concentration of Na, A in 2 electrodes. Concentration of Ha in 2 electrodes. ये दोनों कहाँ से आएंगे? Maybe because of the buffer वाला idea. Maybe because of the buffer idea. Maybe. Buffer का क्या होता था? pH equal to, what is the idea of pH? क्या था? It was something like Ka, pKa plus log of salt by acid. ऐसा कुछ था. Was this the formula of buffer? ऐसा कुछ था क्या? Something like that. याद है? याद आ रहा है? नहीं आ रहा है? A and B. Arman is saying A and B. But देखो अरमान, अगर आप A बोल रहे हो तो ये दोनों भी होगा, C और D भी होगा, है ना? Because मैंने बफर का pH आपको दिखा दिया है. बफर का pH is given like this, है ना? But यार pK does not change. This is a quick way of doing it. These both will change. ये दोनों अलग अलग है. pKa is a constant. So pH, although it depends on pKa and log of salt by acid, this will be different for both the cells. Right? Anode और cathode में अलग होगा. But ये तो same रहेगा. Sorry, ये तो same रहेगा, right? This will be same. So if I were to take an educated guess, अगर मैं educated guess लेता हूँ, then I'll say यार A तो नहीं है, B तो पक्का है और C और D होने के chances काफी high हैं. So अगर मुझे जल्दी में करना होता then I would marks B, C and D. But अगर ध्यान से करना है, we'll do it. ध्यान से करते हैं. A correct नहीं होगा. ठीक है? अरमान, I hope you understand that. Right? What do you guys think? What do you guys think? मतलब होगा नहीं, मुझे ऐसा लग रहा है. We'll solve it. Let's write down the anode and cathode reactions. Right? You know that E is going to be equal to minus RT ln Q by F. Q because E naught is equal to 0. ठीक है? This is out of the way. Okay. And this is a buffer. Okay. So buffer Q because you've got a salt. You've got an acid and salt of its conjugate base. You follow that, right? Salt of conjugate base and acid. कैसे होगा buffer? You get this whole business, right? ये आया तुम्हारा H plus ion concentration, which is the main thing, right? H2 0 to plus 1 to 0. This is just saying there is some H plus ion concentration. ये buffer का क्या मतलब है? कि कुछ H plus ion concentration is being maintained. Okay, that's all that is saying. ये आता है salt से, आता है acid से. ठीक है? So now H plus ion का क्या होगा? H plus is going to be Ka into this value. Now, whereas this and this will be, different. Like say 1 and 2. This is going to be same for 1 and 2. 1 matlab, let's call this half as 1. Let's call this half as 2. ऐसे ही नाम देते हैं हम लोग. Cathode anode लिख लो. तो ln Q इस तरफ है ना. ln Q will be equal to H plus anode by pH2 of anode times pH2 of cathode by H plus of cathode. So you see that clearly हो जाता है cancel. क्या हो जाता है cancel? Ka gets cancelled out. And H plus क्या है? H plus तो I have just told you is Ha by A minus. So that's why HA of anode by A minus of anode times 1 by HA of cathode by A minus of cathode. फिर ये तो है ठीक है, PH2 तो है, प्रेशर ऑफ गैस तो है. खैर सवाल में PH2 तो नहीं है, राइट? सो KA नहीं होगा, बाकी तीनों चीजें होंगी. ठीक है, वैल्यू ऑफ पे किया नहीं होगा, टेम्परेचर यस, HA यस, NA करेक्ट. इज दिस ऑल राइट? कोई डाउट है इसमें? ये कोई नई चीज आ गई, बफर कहां से आ गए? लुक, this is the maximum thing that JEE will throw at you even in the advanced exam. क्या? They will say कि देखो, instead of H plus, we will say कि H plus आता है बहरूपीय की तरीके से from the buffer. By putting a buffer, that's what you're doing. You're maintaining a concentration of H plus. What is that concentration? वो मैंने आपको formula लिख के तो दिखा दिया. And you know, from even if you don't need the formula. I told you कि formula है, but formula की कोई जरूरत नहीं. देखो, from first principle we have figured it out. From first principles हमने इसका figure out किया है. Okay. First principles, proving to you time and again that formulae are okay, but formulae से ज्यादा जरूरी है उस formula को कैसे derive किया गया. If you go just with the formula, right, like PK कहाँ होगा क्या होगा, थोड़ा मुश्किल हो सकती है, but देखो first principle करने से काफी आसान हो गया. All right, excellent, excellent, excellent. अगला सवाल, the EMF of a concentration cell consists of two zinc electrodes. ये वाला बहुत simple है. One dipping into M/4 solution of zinc sulfate and other of M/16 solution of same solid 25 degree Celsius. इसका क्या होगा EMF? बता दो यार, simple है. EMF इसका बताओ. हाँ, मोहम्मद जी, अगम, अरमान, स्वीट, रेक, गॉट इट, दैट्स गुड. इस ये वाला सवाल करो. हाउ डू यू सॉल्व दिस क्वेश्चन? हाउ डू यू सॉल्व दिस क्वेश्चन? चार ऑप्शन है, बट इस सवाल में ऑप्शन की जरूरत नहीं है. आई कुड हैव गिवन यू दिस एज व्हाट डू यू कॉल इट, अ न्यूमेरिकल एंट्री क्वेश्चन आल्सो. हो सकता है, बहुत डायरेक्ट है. कैसे करोगे? द मेन थिंग इज कि देखो, फॉर द सेल टू बी पॉजिटिव, व्हिच मींस स्पॉन्टेनियस रिएक्शन, क्या करना पड़ेगा? यू विल हैव टू पुट कैथोड ऑन टॉप. ओके, that means that this must be the cathode, or is it the anode? सोच के देखो, cathode, anode, उल्टा हो गया. ये हो गया cathode, ये होगा anode, right? How do I know? Because I want to get a positive value of E naught. That's my main idea, right? E naught, sorry, EMF यानी कि E, not E naught. Okay, E naught for a concentration cell is going to be 0. That we all know. C. Arman is saying C. Okay, 0.0178. Let's check it out. Agam was also saying C. Good stuff. So I will write this expression. E equal to 0.059 by N log cathode by anode. How do I know cathode by anode? Because yaar, it is simply LNQ. Okay, LNQ है. फिर से लिखूं क्या? E equal to E naught minus RT by NF LNQ. ये माइनस हो जाता है प्लस, इसलिए हो गया कैथोड का कॉन्सेंट्रेशन. ठीक है, कूल. ठीक है, when this becomes 0, so E then becomes RT by NF 1 by or ln 1 by Q. ठीक है, इसलिए हो जाता है यहाँ पे. ओके, आई एम गोइंग टू रिमूव ऑल ऑफ दिस. ये फिर से लिख के अच्छी तरह से लिख देते हैं. ठीक है, कूल. जस्ट डू दिस. M/4 divided by M/16. Remember that यहाँ पे 2 होना जरूरी है, because you're doing this. This is the reaction, right? और Zn giving you Zn2 plus. So 2 इलेक्ट्रॉन है, ध्यान रखो. So you get 0.059 log 2. So 0.059 into log 2 कितना होता है? 0.3, right? So 0.3 times this gives you this. ठीक है, cool. मतलब 1/3 approximately of 0.059. Cathode anode, yes, absolutely. Nidhi, how are you doing? Yes, absolutely. चलो शुरू किया, ये जाए इस चैप्टर को, इस सेशन को. Let's start this session of electrolysis and electrolytic cells. That's what we're going to talk about in this session. Okay, so electrolytic cell वो है जहां पे non spontaneous reaction को हम लोग spontaneous बनाते हैं. Till now we were talking about all reactions that are spontaneous in nature. मतलब already E naught positive था, हम लोग उससे electricity produce कर रहे थे from chemical reaction. Now it's the other way around. We're using electricity to cause chemical reactions to happen. मतलब by default E naught was negative. Okay. बनाओ श्रीलता. If you need, then please make. You need क्या? You have to make short notes. How are you going to do JEE if you cannot even write notes, yaar? Make notes yourself. You have such beautiful textbooks like NCERT. I am giving you so many names of other books. Zumda, Lebing. You have to make your own notes. If you're expecting somebody else's notes to help you, boss, life is going to be hard. Okay, engineering, how are you going to study all those big fat textbooks? What you're studying in, 2 years in chemistry, you have to study in 1 semester in your engineering. Ask your friends. ठीक है? All right. Yes. So Samyola ji, absolutely right. C was the right answer over there. Chalo, an electrolytic cell is an electrochemical cell in which a non-spontaneous reaction is driven by an external source of current, passing some current. Okay, it converts electrical energy to chemical energy. You already know this. So, for example, I've got water. Literally, I pass electricity, I break its bonds apart, and I get these right here. Now, E cell is negative. Matlab, I have to give enough energy in the opposite direction. So, I have to give at least 1.23 volts for this reaction to happen. That's what this negative 1.23 means. I have to provide at least 1.23 volts. उससे ज़्यादा दूँ, then also it works. But at least 1.23 volts. Okay. If I do उससे ज़्यादा क्या होगा? Think about it. What happens if I give do more than that? Okay. The spontaneous process is a reverse reaction, which means formation of H2O from these two chaps. Okay. Hold on. All right. So at pH equal to 7, this is spontaneous, right? अपने आप you combine water, H2 and O2, and that gives you water. But well, thermodynamically is fine. Kinetically, it's a little weird. Okay, so we won't talk about that so much. So for electrolysis of H2O, the electrical power supply, you need to be at least 1.23 volts. Okay, and this is what the whole setup looks like. Okay, now notice the direction of current. This is important, extremely important. Please hear me out here. Okay, what is anode? What is cathode? We'll figure it out. We'll figure it out. Okay, यहाँ पे कुछ चीजें लिखी हैं. Cathode seems to be like a weird stick. Anode is like a broader thing. Okay, कुछ है यहाँ पे. Positive, negative. Positive terminal matlab it is pushing away electrons. Negative terminal matlab it is pulling electrons. You see this direction? Are you okay with this direction that I've drawn here? Are you okay with this direction? Exam के last 2-3 दिन में hand notes बहुत important होते हैं revision के लिए. Absolutely नहीं थी. हर एग्जाम में, अभी के लिए, बाद में, और खुद के नोट्स जरूरी होते हैं. किसी और के नोट्स कैसे पढ़ोगे? मेरे से तो कभी नहीं हुआ था. अगर if you students are brilliant and you can understand someone else's notes, great. But I have to make my own notes. That's what helps me pass my exams. Has helped me pass my exams all this time. Okay, are you okay with the direction I've drawn over here? Yeah, electron ka direction is going to be this way. No, this is the other way around. Yes or no? जी sir. अरे आप जी बोल रहे हैं निधि, बट बाकी लोग कोई कुछ बोल नहीं रहे. लग रहा है सब लोग सो रहे हैं. देखो, current का direction is positive and negative, but positive मतलब it is pulling electrons, and this is going to be pushing electrons. Okay. So if it is pushing electrons, मतलब reduction यहाँ पे हो रहा है, यहाँ पे हो रहा है oxidation. That is still the same. But this is the cathode. Now it's negative and this is anode, which is positive. Does it make sense? Reduction happens at the cathode. Yeah, reduction will happen at the cathode. Why? Electrons will combine with some positively charged thing. Yeah, with maybe in this case just water. And here oxidation, मतलब पानी itself will give you say O2 and electrons, right? Here this plus this will give me H2. H plus, sorry, hold on. इसका हम लोग पूरा रिएक्शन ध्यान से लिखेंगे. Don't worry. खैर, we'll do all of that. At anode oxidation and at cathode reduction. Okay, great. Electrolyte is a combination of cations. Blah blah blah. ठीक है, कुछ भी लिखे. That's okay. Let's look at the construction of this electrolytic cell. Right? How does it work? Source of current is some sort of a battery. External battery मतलब it can have one cell or many cells. Many cells is battery, right? एक single cell is just a cell. You've studied all that in physics. Cathode is attached to the negative terminal of the battery. It's actually the other way around, right? The negative terminal में आप जो भी connect करोगे वो बन जाएगा cathode. This statement says cathode is attached to negative terminal. मतलब कि I'm pushing electrons, and what will accept electrons? Remember, acceptance of electrons is reduction. So that automatically makes it the cathode. Do you follow this? This is like which came first, the chicken or the egg, right? कौन पहले आया? Here, reduction happens at cathode. And this is a consequence. Yeah, this is not important, but this is a consequence. That negative electrode, whatever. The consequence है एक चीज का. क्यों? Main चीज है reduction. This is the main thing. ठीक है? तो cause and effect. Okay? Cool. Okay. Other way around, anode is positive क्योंकि oxidation यहाँ पे होता है. क्यों? ये oxidation मतलब it furnishes electrons. Remember, I told you that oxidation furnishes electrons. If it is furnishing electrons and those electrons being pulled by the positive charge, okay, by positive terminal, not charge, positive terminal. Sweet. Okay, same diagram फिर से. Namaste Harshit ji, कैसे हैं? Yeah. Let's look at the electrolysis of molten NaCl. ये बहुत simple है, ये आप 9th grade से पढ़ते आ रहे हैं. Same चीज यहाँ पे बार-बार figure दिख रहा है. In अंदर there is no water. Okay, this is important. Just these ions, Molten NaCl means just these ions. Okay. So at the cathode, reduction happens. Okay. At the anode, oxidation happens. How? You're going from 1 to 0. You're going from -1 to 0. And you'll see यहाँ पे 2 electron है, यहाँ पे 1 electron है. If you want to balance the reaction, multiply this with 2, add it up together. You have done this redox reaction while balancing 100 times. उसको add करो ये. Now, E naught cell has less than 0, non-spontaneous. But I make it spontaneous by passing electricity in the opposite direction. Arman ji, class चलेगी 9:30 बजे तक. Yeah, 8:30, 9:30, it's 1 hour class. Sodium metal and chlorine gas are called product of electrolysis. Sodium metal at cathode, chlorine gas at anode. And usually, this happens quite a bit. At the anode, you will get some negatively charged thing losing electrons. At our, हमारे level की बात करो. And giving you some sort of a gas, chlorine, oxygen, all that. And at the cathode, you would either get hydrogen or some metal. Usually, यही होता है, reduction होता है. Normally, this is what happens. And this is interesting because hydrogen is a good reducing agent, but it is getting reduced. मतलब it's a non-spontaneous. Think about it. So थोड़ा सोचो. With everything I'm saying, think about everything you already know from before. You know that hydrogen is a good reducing agent, but I'm forcing hydrogen to get reduced, which means that's a non-spontaneous reaction. I'm causing it to happen. You remember from last class? I don't know if you remember. कि मैंने बोला था कि hydrogen happens to be the zero of E, E value, but that does not mean कि that is the point at which things suddenly become oxidizing or reducing. Hydrogen is a reducing agent. And मैंने पहले बोला था from JEE that 0.8 volts is the voltage at which approximately oxidizing and reducing power is the same. It is not zero. If you don't understand this, it's okay. Ping me on iTeachChem. I'll give you the resources of JEE. मतलब मैं फोटो भेज दूंगा तुम लोगों को JEE की जो तुम लोग आराम से पढ़ सकते हो. If you have JEE, then you can read that on your own. थोड़ा सा advanced का idea, but hey, why not, right? We're doing things आराम से, though. I think we can talk about these ideas as well. Kel, okay. What are the factors that affect the product of electrolysis? The first idea is basically the amount of charge passed, right? अगर तुम ज़्यादा charge pass करोगे, तो ज़्यादा electrolysis होगा. Simple चीज. But charge and voltage are two different things. Charge and voltage are two different things. Voltage is the amount of potential difference. मतलब झरना ऊपर नीचे. And charge is like झरना with a very slow flow or a very heavy flow. Like जब बारिश के मौसम में झरना बहुत ज्यादा होता है, that is a lot of charge. Okay, you have to draw these analogies. This is practical. Okay, cool. Similarly, heat, temperature difference is the same as voltage. Okay, now heat flowing, ज़्यादा heat, कम heat, that's like current flowing. Okay, all right. Arman, ping me on iTeachChem, bro. Lovely. Hello world. That's amazing. It's good to know you're reading this. That's awesome. That's amazing. Arman, ping me on iTeachChem. I cannot take questions on hydrogen oxygen fuel cell right now because that's not what we're talking about. ठीक है? All right. So, amount of charge, it depends on this. Nature of electrolyte. What is nature of electrolyte? We'll talk about it. Concentration of electrolyte. Concentration of it. अच्छा, ठीक है. And nature of electrode. Okay, ठीक है. Let's see. Amount of charge passed into electrolyte is what Faraday's laws are all about. Faraday's laws, and this actually is how the whole idea of electrochemistry even started. Scientists in the late 19th century, they started passing electricity through all kind of chemicals. Like, ooh, what does this button do? You've seen that cartoon, right? Dexter and Dee. Ooh, Dexter, what does this button do? That's how they were like. They got electricity, let's pass it through things. And they were able to deposit some specific masses of silver. Okay, like 0.0108 something, कुछ मतलब some 0.11, some specific mass, 0.0011 something gram of silver what they would deposit with 1 mole of electron. कुछ बहुत अजीब नंबर उनको मिल रहे थे. And they were like, you know what? This number is constant irrespective of what sample we take. And for a different metal, the number is different. So this was the initial, things that they did. And based on this, they formed these laws. What are these laws? Amount of product of electrolysis or the mass of substance is deposited on the electrode. We're talking about kitna quantity deposit ho raha hai, okay, on the electrode. So technically we're talking about reduction. What does this mean? If something is being deposited, maybe it is some metal. Okay. Is this या होल्ड ऑन, हमने कुछ गलत लिखा, या यहाँ पे should be plus n electron gives me metal. So this process is reduction. Do you understand that? Faraday's laws are talking primarily about reduction. Theory idea JEE में पूछ सकते हैं, theory कितने how many of these statements are correct for that kind of a question. ठीक है? This chapter is not in JEE Hello World. This chapter is in Zoomdal. Please read it from there. Or for Ebbing. Zoomdal is for JEE Advanced. Ebbing is for JEE Main. Okay? But Zoomdal can also be used for JEE Advanced, but know where to stop. ज़्यादा पढ़ोगे तो दिमाग में ये क्या है? थोड़ा एक्स्ट्रा है Zoomdal में. Questions wise at least. ठीक है? I'm not angry with anybody, bro. Why will I be angry with you? You are amazing people. Yes, Nidhi is absolutely right. आप एक बार लिखोगे, आप मैं पढ़ूंगा. आप 10 बार लिखोगे, there is a high chance of me putting you in a timeout. Pretty high chance. But since you guys are new, I'm just going to mention this एक बार आपके लिए. एक बार बोलो, I will read. Nidhi, thank you. AK Gaming wants to get to the point. M is ZIT. Yes, let's get to the point. What is this M equal to Z? We'll talk about that. The mass deposited release of any substance during electrolysis is what Faraday's first law tries to say. So mass, as AK Gaming has pointed out, has something to do with charge. Okay, it's proportional to charge, and that is I into T. That Z he is talking about, we'll figure out what that Z is. It's proportional to amount of charge. Okay, M is proportional to Q. Okay, and the proportionality constant is Z, as your friend has rightly said. ठीक है? So anode, cathode दोनों में मेरे पास कॉपर है. देखो मैं पास कर रहा हूं करंट. Look at that. At the cathode deposition happens. I don't know if you can see it clearly, right? देखो फिर से एक बार चलने दो. Cathode देखो बड़ा होता जा रहा है. Deposition, this is becoming thinner and thinner. So this is basically how electro refining also happens. ये copper is pure, ये है impure, and नीचे गिरता है anode mud. ये सब पता है या नहीं पता है? ये सब पता है? I know मैं GIF के ऊपर लिख रहा हूं, but देख लो, ठीक है? Anode, cathode, impure copper, pure copper. ये सब मग करने की बात नहीं है. I am the worst at mugging, but I figure things out because I am sure about the concept. What concept did I use here? Anode पे होता है ऑक्सीडेशन. ओके, मतलब कि कोई मेरे पास इम्प्योर चीज है जिसमें मुझे प्योर करना है, और कैथोड पे होता है रिडक्शन, तो कैथोड प्योर होना चाहिए. कैथोड होना चाहिए प्योर कॉपर. इम्प्योर कॉपर जाता है वहां पे सॉल्यूशन में, और इट्स नॉट नेसेसरी दैट द सेम कॉपर आयंस गो देयर. ओके, ऐसा नहीं है कि यहां से जो कॉपर आयन है सेम कॉपर आयन वहां जा रहा है. ये वाले जा रहे हैं इधर इन CO2+, and this some random ions are going from here to. Think about it like a bank, right? Your electrolyte is like a bank. मैं उसमें पैसे डाल रहा हूं और मैं पैसे निकाल भी रहा हूं, बट जो नोट मैंने डाला, that same note I will not get, right? I'll get some other note when I deposit, when I take money out. That's the analogy that works the best for this. छोटा सा इलेक्ट्रो रिफाइनिंग ही पढ़ा दिया. इलेक्ट्रो रिफाइन कौन पढ़ाएगा 10 मिनट में? This is it. This is all you need to know about electro refining. चलो, what is Faraday's first law? ये जो मास डिपॉजिट हो रहा है वो कैसे फिगर आउट होता है? W, or the weight, is proportional to Q, and the proportionality constant is Z, which is known as the electrochemical equivalent of the substance that our gaming friend was talking about. We'll talk about that in some detail. What is electrochemical equivalent? यही वो बोल रहा था, सिल्वर का बहुत छोटा मास होता है, 0.0118 कुछ होता है. खैर, अगर चार्ज है 1 कूलम, दिस इज जस्ट लाइक F equal to ma. M क्या होता है? What is M? Right? Same चीज. Take acceleration 1, blah blah, वो सब करो. Take charge as 1 coulomb. Then the mass deposited will be equal to Z. Okay. The mass deposited or liberated when 1 coulomb of charge is passed into solution. You know where I'm going with this? What is 1 coulomb of charge? This is 1 mole of electrons, which is 96,500 farad. Right? अगर आपने थोड़ी सी भी फिजिक्स पढ़ी है, you know that the capacitance 1 microfarad, 10 microfarad, 50 microfarad, बहुत ज्यादा होगा, 50 तो बहुत बड़ा हो गया, 2, 5, these are the values that you get in the lab. Microfarad में आप लोग बात करते हो, and यहाँ look at this, I'm talking about 96,500 coulomb. Okay, 1 farad is equal to 96,500 coulomb. Sorry, physics I'm not good. ठीक है, 96,500 coulomb is 1 farad. मतलब बहुत कम हम लोग चार्ज नॉर्मली यूज करते हैं. So 1 mole of charge is a lot of charge. It's a lot of charge. Yes, theory पूछी जाती, निधि से पूछो, निधि है IIT दिल्ली में. She always graces us with her presence. She is amazing. King fan. That's an interesting question. I mean, जो आपको comfortable लगे आप चलो, मतलब उसमें मेरा input, how will my input be useful? मुझे physical अच्छा लगता है, I will start with physical. आपको organic से you start with organic, whatever you like. हाँ, example of Faraday's first law is Na plus electron. Actually, you know, Na plus is not a good example of Faraday's first law because sodium is quite annoying to deal with. Let's talk about copper or something like that. Copper, silver, jo, you know, are easier to do this. Uska sodium, I'll tell you why sodium is not a good example. Huh? I'll tell you why sodium is not a good example. I'll give you examples as to why sodium is not a good example. क्योंकि जब तुम सोडियम और पानी में डालोगे, we'll look at that. Don't worry. Okay. Anyway, later we'll talk about that. Z, remember, we're talking about 1 coulomb of charge. मतलब it has something to do with equivalent mass because something to do with 1 mole of electrons. Okay. So mass of substance will produce when 1 mole of electrons are passed through solution or during electrolysis. यही मैं अभी तक बोला है. तो what is equivalent mass? This is the molar mass divided by number of moles involved in oxidation reduction. ये है n factor का आइडिया यहां पे आ गया. Mass divided by n factor is equivalent mass. Okay. So far so good. Okay, cool. So for silver थोड़ा सा डाइवर्ट करते हो, not really डाइवर्ट करते हो, इसी चीज में हम बात कर रहे हैं. For silver the equivalent mass is simply the molecular mass itself. For copper it's going to be this. When you're going from copper 2 plus to this, going to any doubts with this is okay. Nand, पढ़ाई करो. First and the last time I'm telling you, if you're going to spam here, I'm going to put you in a timeout. ठीक है? पढ़ना इलेक्ट्रोलिसिस तो पढ़ो. So is this okay? Yeah. All right. There you go. टाइम आउट डालने. क्या यार तुम लोग क्यों टाइम पास करते हो? पढ़ाई करो ना. रिवीजन प्लान तुम अभी क्या कर रहे हो? रिवाइज अभी नहीं करना चाहते हो? जब पढ़ाई चल रही है, you want to spam. What is this, bro? ठीक है. All right. For aluminium, it will be equivalent mass will be molecular mass by 3. Cool. Okay. Now, what are they talking about? 1 mole electron is 1 farad of charge. 1 farad is 96,500 coulomb. 96,500 coulomb जाएंगे तब आपको E ग्राम ऑफ मेटल डिपॉजिट होगा. E मतलब इक्विवेलेंट मास. Okay, cool. So what is Z? Z was electrochemical equivalent. Electrochem equivalent, which was what? When you pass 1 coulomb of charge. 1 coulomb of charge. Not 1 farad. 1 coulomb of charge. So you divide E by 96,500. You get Z, which is what? Which is molar mass divided by n factor times क्या था वो? F, right? RTF, yeah, F, exactly. बस, right? That's it. So Z is equivalent mass by 96,500. यही चीजें आपको जरूरत है. Okay. So W equal to Q times Z, and that means this. And in fact, it's going to be ZIT. That is the best way to remember it. Even I remember that. AK Gaming बोल के भाग गए. ठीक है? Are we good with this? How do you get Faraday's first law? कैसे आता है? What is the value of E? Sometimes examiner student blank out. They blank out कि भाई E क्या होता है? E ठीक है, Z क्या होता है? कभी-कभी they just write E there instead of Z. So please don't do all those things. All right, sweet. So the mass is simply going to be equal to molar mass by n factor into I into T divided by 96,500. This is the summary of the first law. Okay, just going to write it down. I think मैं M में थोड़ा mess up कर दिया. Summary of first law. एक सवाल लेते हैं. Find the number of electrons involved in the electrode deposition of 63.5 gram of copper from a solution of copper sulfate solution. Okay. कितने electrons चाहिए? How many electrons to deposit 63.5 gram of copper? बताओ. What do you think? नंद भाई, अब आपकी बात की जाएगी. बोलिए क्या बोल रहे थे नंद? How do I remove your timeout? I don't know how to do that. You spam. I have zero tolerance for spam. So, no, I don't know how to undo your timeout. खैर, 5 मिनट बाद आना बताना whatever you're talking about. इस सवाल का जवाब दोगे आप लोग मुझे? Find the number of electrons involved in the electrode deposition of 63.5 gram of copper from a solution of copper sulfate. So you've got Cu2 plus giving you Cu, and the mass they're saying is 63.5 is what you need to get. How do you do that? कैसे करेंगे आप? बताइए. Do you need a hand with this? You need me to help you out with this one, और आप लोग try करोगे. So remember, the main thing is 2 electrons transfer हो रहे हैं, right? So small hint is Cu2 plus to Cu. So 63.5 gram, which is basically the mass of 1 mole. Have the periodic table out, guys, if you're not sure there's a mass. This requires 2 equivalents. 1 equivalent में कितने electrons थे? You know this, 1 mole. 2 equivalents में होंगे 2 moles. That's it. 2 mole is the answer. Pranam, good evening, Madhul. Arya, how are you doing? So the answer is simply 2 moles. What is 2 moles? 2 into 6.022 to 1 in 10 power 23, which is 12.044 in 10 power 23. Cool. पहला सवाल, I thought I'll do it for you guys. अगला वाला आप लोग करना. Any doubts in this question? Sasta, Sundar, Tikau. Easy question. Yeah. But teaches you the basics of everything that's going on here. Any doubts in this question? Shall we move on to the next idea? Please bataiye if this is okay. Shall we move on to the next question? Any doubts here, guys? Rek, Arman, Mradul. There are a lot of questions we have planned for you today, and the whole idea is कि भाई आपको सवाल practice करनी पड़ेगी. That's the only way to get through electrochemistry, right? You must solve questions. All right, sweet. Yeah. Nidhi, 12 part 23. Yes, 12.044. The reason, by the way, Nidhi has written 12.045. Yeah. The reason why I've taken 12.0 as the answer, by the way, significant units, right? Significant figures and all of that. You've got 3 significant figures there. So यहाँ पे भी 3 ही होने चाहिए, इसलिए मैंने 12.0 लिखा है and not 12.045. Yeah. Take care of a few details here and there. Care. A current of 0.5 ampere when passed through AgNO3 solution for 193 seconds deposits 0.108 gram of Ag. Find the equivalent weight of Ag. In this case, maybe you just know the answer, you mark it quickly and go on. But it's okay. ये ऐसा सवाल JEE में नहीं आएगा. Not like this directly at least. But try it out. Assume that you don't know the equivalent mass of Ag and try and calculate it. Yeah? You don't get the equivalent part, Nityashri? I'll explain once again. I'll explain. Slide number 47. Slide number 47. 1 minute. There is a bit of a, extra dot there that I want to remove on this question. Let me quickly do that and I'll explain to you. 193 seconds. Why is there a full stop here? There shouldn't be a full stop here. Be gone, full stop. Chala gaya, full stop. While you guys try this question out, Nitya asked me, Nityashree has asked me, 108, Arman, yeah, easy one. Sure. All right. Absolutely. Good stuff, Arman. Nice. Nidhi, 108, sweet. Quickly gonna explain to Nityashree what this equivalent idea is. देखो यार, Nidhi, you don't follow equivalents, huh? You follow moles? You understand moles? Number of equivalents is simply moles times n factor. Okay. What is n factor? N factor is number of electrons that interact with 1 mole. Now in this case, this is going to be 2. I have proved that to you by putting this here. Okay? So n factor is 2. Mole have 1. So number of equivalents is 1 into 2, which is 2. Nitya, is that okay? Nityashree, is it okay if I call you Nitya? Yeah? Is that okay? If not, you have to revise the concept of equivalents, right? Equivalent hoti kya cheez hai? Because that is central to everything we do here, right? Because equivalent mass is there, etc., etc. And equivalent mass is simply molecular mass divided by n factor, right? Cool. I'm going to move on to the 108 wala question. Yeah? And quickly put that down here. W is ZIT. Yeah? Z is what? Same cheese, Nitya, and everybody else watching this later on as well. You've got E over here, which is the equivalent mass, which I don't know, right? And I know that 96,500 coulomb is the definition. That's basically 1 farad, right? Per equivalent. So I cancel this out, and what I get is gram per coulomb. Remember, Z has units of gram per coulomb or kilogram per coulomb, right? So I'm getting the same units here. Make sure you always check unit sahi hai ki nahi hai. Yeah. Why about gram per equivalent? See, a mole is gram per mole. Equivalents is grams per equivalent. Same cheese. The denominator is equivalent instead of mole. Okay. So 0.108 is the mass that's given out. Z I don't know. 193 into 0.5. So I put this down as all of this and everything nicely cancels out. Yeah, this into this is basically equal to 96,500 itself. And times 10 power 3, right? Is what you get. 108 gram per equivalent is the mass. Just like you say 108 gram per mole. Same way I've written down, it says 108 gram per equivalent. Okay, sweet, good. Chalo, move on to the next one. Nand, welcome back, bro. वो पूछो क्या पूछ रहे थे? You wanted a revision plan, ना? The plan for revision is, hold on, I'm going to open up my, नहीं, it's okay, अभी तो sorry भी 10 बार मत बोल यार, फिर से एक टाइमर डालना पड़ेगा. Don't say sorry 100 times, it's cool. I understand your भावनाओं को मैं आपके समझ रहा हूँ. रुको, मैं कैलेंडर खोल के बताता हूँ क्या प्लान है. कैलेंडर देखना है, ये मेरा खुद का कैलेंडर है, ठीक है, तो इसलिए like yeah, everybody else is making their plan. I'll tell you when I'll start this. Hold on, where are we at? JEE, thermodynamics, electrochemistry. Electrochemistry तो हो रहा है काफी. 23 नवंबर आज का डेट है. वन शॉट. रिविजन 30th से शुरू हो रहा है नीट चैनल पे, और 28 नहीं 25th से शुरू हो रहा है नीट चैनल पे, और 28th आई वांट टू से 30th नवंबर से शुरू हो रहा है मोल कॉन्सेप्ट. एंड या दैट्स द प्लान. 30th नवंबर ऑनवर्ड्स फॉर मोल कॉन्सेप्ट. I'll do every chapter in physical and organic chemistry. That's my plan, Nand, since we asked. Okay, cool. For revision, one chapter in 1 hour, and we'll do like whatever I have. How many other chapters are there in physical and organic chemistry? I'll do those. Nitika's already started, right? Nitika's already started doing organic chemistry. How do you like those sessions? They are amazing, right? Nitika's brilliant. She's been here with us since 2019. Great teacher. Yeah, great screen presence. Total charge required. देखो अरमान सीधे देते हुए आंसर, उनको नहीं चाहिए टाइम पास. एक्सीलेंट अरमान, थैंक यू. Total charge required for the oxidation of 2 moles of Mn3O4 to MnO4 minus in an alkaline medium is, Arman, beautiful man, amazing. Arman says 20 farad. Do you guys agree with Arman, or do you want to like, or Arman, can you explain to us what did you do here? Can you tell us, the rest of us who are just, trying to figure it out, how do you do this question? कैसे शुरू करते हैं? How do you start this question? Because you've been given total charge required for the oxidation of 2 moles of Mn3O4 to MnO4 minus. Mn3O4 is a weird thing, right? It's like, it's not MnO2, it's Mn3O4. Mn3O4 का oxidation state क्या होगा? 8/3. I need the oxidation state. Oxidation number, I need the oxidation number. इसीलिए redox और electrochemistry को साथ में क्लब किया जाता है. Because redox is a central part of electrochemistry. Arman, I get you. But how did you get 20 farad? Can you tell us? What did you get? What did you do to get to 20 farad? Thank you for the answer. Help your friends. So what is the main redox idea that you need to use? Reduction. Reduction? Reduction. Reduction? Oxidation. Reduction होता है electrolysis में. यहाँ पे हम लोग कर रहे हैं oxidation. Oxidation कर रहे हैं. Oxidation कर रहे हैं. ठीक है, करते हैं oxidation. Okay, ठीक है, oxidation चाहिए. Arman is saying, Nidhi is also 20 farad. Arman is saying Mn plus 8/3 is equal to plus 6. Okay. Mn plus 8/3 equal to plus 6. What does that mean, Arman? Can you just talk about it a little more? Plus 8/3. Okay. Mn3O4 becomes MnO4 minus. Okay. यहाँ पे है. So what is the oxidation number of this Mn3/4? It's 8/3, as Arman correctly pointed out. Right? 8/3. And जा रहा है to plus 6. Excellent. Okay. I think वो arrow बनाना चाहते हैं. Arman wanted to do this. He wanted to draw that arrow. ठीक है, मैं समझ गया. And here it's plus 6. So which means I'm going from plus 8/3 to plus 6. This is oxidation. Okay. Now things get interesting. अभी आपको उसको करना पड़ेगा balance. Now this is for 1 mole. All of this is 1 mole. But I need 2 moles. उसके बाद हम लोग balance करेंगे. Then we'll do the 2 mole process. Why do we need to balance? Because if I find out कितने electrons चाहिए 1 mole के लिए, then double that is 2 moles. As simple as that. How do you balance this? What is the main thing? Okay. सोचने दो. कैसे करें इसको? I have to put a 3 here, right? I need to put a 3 here. Why do I need to put a 3 here? Because there are 3 atoms here of manganese. So I'll put 3 atoms here. But if I do that, एक atom का 8/3 था, अभी 3 atoms हैं यहाँ पे, तो it will be 3 into 8/3. Do you see that? 8/3 was for 1 atom. And for 3 of them, it's going to be, well, just 8. So the total oxidation number is changing from plus 8 to whatever number here, plus 6. Okay, so 3 into minus 2. Achha, so यहाँ पे 6 electrons. Okay. So things are getting interesting, but still a little complicated because there is a lot of क्या बोलते हैं oxygen atoms that are extra over here. What do I do with this? I can go around trying to balance oxygen atoms, or what I could also do is that, look, the oxidation number is changing from 8 to 18. How 8 to 18? Here, see, I'm going to write that again. 8/3 into 3, okay, Mn on LHS. Mn on RHS is going to be simply 6 into 3. Why? Because there are 3 atoms of manganese. So, since it's changing from 8 to 18, I can just say कि boss यहाँ पे 10 electron है. 10 electron है. ठीक है, cool. Yes, absolutely right, Arman, thank you. Did you follow this way of balancing that I did? It's a shortcut. You can go in detail, balance the oxygens, put H plus. वो आप कर सकते हो, right? Add 10 H plus here. No, not 10 actually. You have to add 16 H plus, right? Why 16 H plus? Because 10 electron plus 6, right? So 16 H plus. वो सब कर सकते हो, but वो जरूरत नहीं है अभी. Maybe that's not necessary right now. ठीक है? And you'll have to add some water on this side also because there's 4. This is like oxygen balance नहीं है. I just need to know electrons. इसलिए this is a shortcut of balancing. I'm only focusing on manganese का oxidation state. Do you see why I did that? Focusing only on manganese का oxidation state because बाकी चीजें don't matter. H plus होगा, पानी होगा, वो सब होगा, but doesn't matter right now. Okay. So for 1 mole, I have 10 electrons or basically 10 farad. For 2 mole, I have 20 farad. That's the answer. Any doubts? Thank you, Arman. Thank you. Excellent work. Nidhi, great work as well. Any doubts on this? Ki how do we get 10 farad? Once you get 10 farad or 10 electrons, is the same thing, right? देखो, एक atom के लिए, एक atom give me 10 required 10 electrons. So 1 mole of atom will require 10 moles of electrons, which is 10 farad. 10 farad is just saying 10 mole of electrons. Why? Because it's 1 mole. I have 1 molecule here, not atom. Sorry, 1 molecule. This is 1 molecule and I need to go to 1 mole of molecule. This is why this. All right, ठीक है, चला जाए to Faraday's second law. पब्लिक बहुत शांत हो गई है. जब मैथ्स थोड़ा ज्यादा तो पब्लिक शांत हो जाती है. It's okay, no problem. So when you pass the same charge, this is Faraday's second law. When you pass the same charge through 2 electrolytic cells and cells are connected in series, then the mass deposited on the electrode will be in the ratio of their electrochemical equivalents. और इन द रेशियो ऑफ द इक्वलेंट मासेस का दो चीज हो रही है. एक तो सेल्स आर कनेक्टेड इन सीरीज. इफ सेल इज कनेक्टेड इन सीरीज देन पोटेंशियल दोनों के अक्रॉस अलग होगा, राइट? थिंक अबाउट इट लाइक दिस. अ सेल इज व्हाट यू गॉट दिस, राइट? सम रेजिस्टेंस है, मतलब देयर इज अ ड्रॉप इन पोटेंशियल अक्रॉस दिस एंड यू गॉट ओवरऑल सेल कुछ है, प्लस माइनस कुछ है, ठीक है? बट the current is same. सीरीज का क्या मतलब है समझ लो भाई, पैरेलल नहीं है. ये भी थियरी में पूछ सकते हैं, जेई में एडवांस में, मेन में. सीरीज मतलब सेम करंट. Why series? So always for electrolysis, always you are going to connect cells in series. If you don't do that, you will get different amount of current in everything. If you get different amount of current, different mass over deposit. Khair, okay. So the potential drop will be different across these two sort of resistors, right? Resistor में ऐसी बना के you can draw anything, you can represent anything by a resistance or a inductor or a capacitor, right? You know this, वो सब तुमको मालूम है. उसके बारे में not going into details over there. खैर, anyway, I will not write resistance and all of this. ये सब छोड़ दो. Okay, let's just go with कि I is same in series. ठीक है? Okay. Yes, because same current. Yes, exactly. Cool. So, but if I connect them both, then since the current is the same, now you have basically, you have W equal to ZIT. Okay. So if I say W1 is equal to Z1 times IT, W2 is Z2 times IT, then you basically you're just saying, ki, oh, W1 by Z1 equal to W2 by Z2. That's all you get. Because current is the same, time is the same, because charge is the same. That's all. So, like, how is the different law? It's the same first law, pretty much. It is just an extension of the first law. ठीक है? Cool. That's all. That's all there is to this one. एक सवाल किया जाए. Okay. Okay, so पहले we can look at this nice graphic that shows you if you pass current, so same amount of current through 2 different cells. Okay, hold on. What happens here is silver deposition is a lot more than copper, it looks like. Oh, nahi. W2 is a lot more. W1 was 10 gram, W2 is 31 grams. What is that about? Was that correct? That didn't make sense. एक सेकंड फिर से देखते हैं क्या था. क्या हो रहा है यहाँ पे? 10 है या 100 था इधर? Let's see the graphic one more time. That sounds weird. Oh, 10 ampere current. Okay, 10 ampere current है both. Okay, cool. 108 grams. हाँ, see, it makes so much more sense. Like ये क्या है? 10 ग्राम कैसे होते हैं? 108 grams. Yeah. सिल्वर का डिपोजिशन काफी ज्यादा है as compared to copper. Ooh, we can get rich. हम लोग डालेंगे इतना सिल्वर, निकाल लेंगे सिल्वर. Sure, dude. The point is silver is heavier than copper. इसलिए ज्यादा निकलता है. That's all. ठीक है? So you pass the same amount of current through silver and copper, you will get more silver because उसका mass ज्यादा है. Its molar mass is more. Since its molar mass is more, and equivalent mass also is higher. Molar mass does not matter. Equivalent mass is higher. Equivalent mass is 108, and copper का equivalent mass कम हो जा रहा है. From 65 is becoming 60, whatever. 3 is becoming half of that because 2 moles of electrons react with 1 mole of copper. Yes, AK. AK is still here. Good stuff. Good to see you here. ठीक है. One extra bit of information. Current efficiency is the charge actually used in electrolysis divided by the charge passed. This is because look, in every real cell, थोड़ा से losses होंगे. You would assume कि there are no losses, but losses होते हैं. This is just to talk about it. Let's look at a question. Question लेते हैं. बहुत समय, बहुत theory हो गई. We have around 10 more minutes. I think we can solve a few more questions and we'll call it a day. Questions हैं? हाँ, कुछ questions कर लेते हैं. Electrolysis of dilute aqueous NaCl solution was carried out by passing 10 milliampere current. The time required to liberate 0.01 mole of H2 gas at cathode is what? Okay. तो dilute aqueous NaCl. अच्छा, तो complicated हो गया भाई life. Dilute aqueous NaCl. ये तो मैंने आपको पढ़ाया नहीं अभी तक, but पढ़ाता हूं आपको. I'll teach you that, right? Because you'll be like, wait a minute. आप तो बोल रहे थे कि Na और Cl होता है, but सोडियम के बजाय हाइड्रोजन आ रहा है. हाँ, because when I do aqueous solution, there are two competing reactions. पढ़ा दूंगा, don't worry, अभी very soon. But I'm sure you already know this, right? H plus from water. Or if I were to write it, you know, in a more, what do you call it, realistic way, this is what is happening. ठीक है, बैलेंस कर लेना है तुम लोग, बट बेसिकली दिस इज व्हाट इज हैपनिंग. हाँ, इंटरेस्टिंग, राइट? इज दैट बैलेंस? नो, इट्स नॉट. ठीक है, तुम लोग कर लेना बैलेंस. बट बेसिकली वाटर एक्सेप्ट्स इलेक्ट्रॉन्स एंड गिव्स यू H plus and H2 plus OH minus. Balance this, please. Sir, solved. B. Arman is saying B. Nidhi is saying B only. हाँ, गलती से 8 तब क्या? It's okay. Multiple आंसर नहीं है, multiple करेक्ट नहीं है. It's okay. Got it. तो ये दोनों compete करते हैं, right? That's why हाइड्रोजन यहां से निकलता है. क्यों हाइड्रोजन होता है? We'll look at that. Don't worry. We'll look at that. हम लोग उसको theory में जाते हैं. But since you guys have got it so quickly, I'm gonna go ahead and solve it. H2 requires 2 times 0.01. Lovely. 2 चाहिए उसको. Okay, sweet. So NaCl gives me Na plus Cl minus. So, and you also got these two reactions are basically happening, right? At the cathode and at the anode. But this one does not happen. Yeah? इसके बजाय ये हो जाता है. This is the balance reaction for that I was struggling to balance at that point in time. Is this balanced? Oh gosh, this is not balanced. Oh wow. Well, let's put a half here. Then it will get balanced, right? Yes, it gets balanced. Lovely. ठीक है. I really hope that's balanced now. खैर, yes, 2 electrons चाहिए हाइड्रोजन को निकलने में. तो yeah, that's the main idea that you need to hold on. I think we should balance this. Can you tell me what is something seems fishy over here? अगर 2 इलेक्ट्रॉन यहां हो गए तो 2 यहां पे हो जाएंगे. 2 और 2 4, तो ये हो जाएगा 2. अगर ये हो गया 2 4, this now looks like it is balanced, which means कि per molecule, yeah, which is the same thing I was doing earlier. Wow, half मैं वहां पे डाल रहा था, was the same thing. And then this becomes 4. But if I'm doing 2, then I get half. Is this balanced? Does it look balanced to you? Hey Shankar, long time. Khair, 0.01 mole has 0.02 equivalent. That's what we're getting at. Okay? But that requires this to be balanced. This balancing is bugging me. Can you guys tell me how this balances out? Did I miss something here? Please help me with this. How did you guys solve it? पता नहीं क्यों मुझे लग रहा है कुछ अजीब हो रहा है. Electrolysis of water. I did write it like this, but it seems a little shady now, right? And I'm assuming that this is happening in a basic medium right now. If I assume that it happens in an acidic medium, तब क्या होगा? Now, is this anode? Is this cathode? We're talking about cathode. Cathode में reduction will give you 2H2O plus 2 electrons. Yeah, तो सही था. Yeah, yeah. It's good to put this 2 over here and 2 over here. Yeah, this balances out nicely. Yeah, this makes sense. ठीक है. वो half वाला thing does not make sense, right? Half will be for one electron. Now I'm convinced. Yeah. So 0.01 mole of what you call it H2 निकल रहा है, मतलब उसके equivalent है 0.02. Once you've got that, then life is simple. Q is simply I into T. I is 0.02 into 96500, which is this thing, the coulomb is got, this is the charge, and 10 power minus 3 into T. Why 10 power minus 3? Because 10 milliampere. Milliampere matlab 10 power minus 3. Milli is 10 power minus 3, right? That's it. Yes, 0.02. When time happens to be 1.93 10 power 6, which is 193 into 10 power 4, which is the answer. Excellent work. Next question. 4 moles of electrons were transferred from anode to cathode in an experiment on electrolysis of water. The total volume of the two gases, dry and at STP produced, will be approximately what? Yes, thank you, Arman. You're amazing, man. That's okay, Shankar. Koi tension nahi hai. Sheetal. Welcome. Good to see you here, huh? So both JEE and NEET. Sahi hai, Sheetal. Yeah. Try this question out, guys. 4 moles of electrons were transferred from anode to cathode in an experiment on electrolysis of water. So now, this is a small hint, right? Electrolysis of water can happen in an acidic or a basic medium, either be. But you choose which one. And ये तो आप redox reaction में कर चुके हो. In redox reaction, you have done this in detail, okay? But a small hint, so to speak. The total volume remains the same. Whether you have anode, whether you take acidic or basic medium, doesn't matter. ठीक है? But take one, pick either acidic or basic medium. मतलब कि in your equations, you will either have H plus or OH minus. Don't put both. Don't put both. या तो H plus या OH minus आएगा. Solved. Arman, बताइए. Arman, on fire. Okay, sweet. बढ़िया है. But your answer is 67.2. I know why your answer is 67.2, Arman. Because you took pressure to be 1 atmosphere. ठीक है? But pressure is 1 bar. नहीं? Arman? 67.2 is it? Calculator निकालते हैं. Calculator क्यों निकालते हैं? 3 into 22.7. I'm shameless. Exactly 68.1 आता है यार. When you take 22.4 into 3, then you get 67.2. है ना? समझ में आया? C is the right answer. But you see why I have taken 68.1, because NCERT definition बदल ना. STP pressure is now 1 bar. NCERT says 1 bar, not 1 atmosphere. So don't take 22.4. Take 22.7 as the volume of 1 mole of gas. That's जरूरी है. ठीक है. कैसे किया जाए? Assume acidic condition. You can assume basic also, doesn't matter. Just to write the equation. ठीक है. मतलब H plus react कर रहा है इसके साथ, yeah? Because I've taken acidic condition. I could also do the same thing in basic condition. कोई tension नहीं है. In this reaction, there are 4 electrons. In this, there are 2. So I multiply this one with 2. Now, for 4 moles of electrons, oh, that's great. सवाल में ही 4 mole लिखा था. यहाँ पे हम लोग बैलेंस करने के बाद भी 4 mole हो गया. 2 into 2 हो जाएगा, right? So this is 4 mole. Awesome. So for 4 moles of electrons, कितने mole मिल रहे हैं? 2 plus 1, which is 3 moles. है ना? 2 moles of hydrogen plus 1 mole of oxygen, which is 3. 3 into whatever, 22.7 is 68.1 liter. Sweet. Yes, Sheetal is absolutely right. जितने ग्राम equivalent, उतने Faraday. Same funda, दोस्तों. I like it. Arman, I like it, man. You're on fire, Arman. But be careful, huh? वो 67.1. हाँ, Nidhi, you think it's 67.1 and not 68.2? देखो दिया हुआ है STP. Isn't standard pressure 1 bar? That's what NCERT is saying. If standard pressure is 1 bar, then at 1 bar, the volume is going to be equal to 22.7 liter. है ना? I don't know. I'm just saying. Like, shouldn't you be careful about that? Right? Especially अगर numerical entry है, be careful about this. 22.7 and not 22.4. Small bits that are remaining, which we can quickly cover. Yeah? कि जो product obtained है depends on nature of electrolyte. मतलब या तो molten है या तो aqueous है. Molten तो बहुत straightforward है, right? Molten I've already done with you. NaCl था वैसे ही NaF है. The only difference that I want to talk to you about is look at these values. They're very interesting. Okay? They're very interesting. This is not E0 reduction. This is E0 for this reaction. Do you see that? This in fact is E0 oxidation, and this is E naught reduction. And both of these reactions, beautiful thing to just notice here, both E naught reduction and E naught oxidation are negative, which means both processes are non-spontaneous, but I make them spontaneous by passing electricity. That is what electrolysis is all about. बहुत जरूरी बात है, that I am leaving to the end of this session. Lecture almost खत्म हो गया, तो ध्यान से सुनो. I know there must be a fatigue setting in. It's been an hour. This is important, extremely important. E naught reduction, E naught oxidation. Okay, remember, जो E naught reduction है F का, that's highly positive, right? F2 expecting E2 electrons, that value is plus 2.87, but मैं उल्टा लिख रहा हूं उसका, so this is E naught oxidation and it's very negative. Same with E naught reduction of say sodium. Sodium, you know, does not, अगर sodium ion बन गया, it's really happy, does not want to form Na, that is also negative. Okay, so this process is insane. Okay, cool. All right, so is that okay? Okay, molten वाला straightforward था, but these values are important. Okay, why is it negative? बाल की खाल उदाहरण यहाँ बहुत जरूरी है. अगर aqueous हो गया तो things get a little complicated, right? Then you also have water that competes usually. Okay, water कैसे compete करता है? Main idea यही है, अगर दो चीजें compete कर रही हैं, जिसका भी जो है ज्यादा आसान हुआ, that will get out of the solution. ज्यादा आसान मतलब well, smaller value, physically smaller value. Yeah, smaller value of what? Look at this here. Out of these two, अगर मैं, if I have say a battery and I have to either give it 0.8 volts or I have to give it 2.71 volts, which do you think will happen faster? Easier. This, which is why hydrogen gets deposited, hydrogen comes out of the solution, not deposited, sodium will get deposited. So when I'm comparing sodium and hydrogen, the reason why hydrogen comes out, even if I provide say 2.71 volts, मैं provide करूं भी, तो 2.71 volts से काफी पहले ही ये हाइड्रोजन पहले निकल जाएगा, because that is easier for it to get out. Do you follow this? अरे नहीं शीतल, ये ट्रिक नहीं याद की जाएगी. I don't know what that is. We are not mugging that. I am never doing that. शीतल, there's only one thing that I'm strongly against in chemistry, which is mugging these acronyms. Sorry. I'm really sorry, but that's not something that I will ever promote. I have never done it in my life, and I will never ask my students to do it. Are you following this, guys? Why is it that out of these two, hydrogen gets out of the solution? Okay. You'll be like, wait a minute. Hydrogen का standard electrode potential 0 होता था? Sure. Standard electrode potential 0 होता था. But पानी से, from water, if I'm making water accept electrons and then hydrogen comes out, that is not 0. Okay. That is going to be negative 0.83. And remember, what is this? This is reduction. And this is also reduction. So out of these two, ये वाला होगा because this is a smaller value. Okay. No tricks required. No tricks required. NCERT की इसे उल्टी दी increasing out of SRP. It's okay. Doesn't matter. Doesn't matter. Arman, I feel for you, man. All the best with everything. What happens with anode? Anode में भी यही चीज है. जिसका हुआ छोटा value, that will come out first, which means oxygen comes out. But you need to make sure that you write anode reactions. Don't write cathode reactions for anode. Okay. I know you are used to E naught reduction potentials. यार बदल लो ना. Reverse the reaction, change the sign, it's okay. So you see, out of these two, the smaller value, right? Again, if E naught is thoda chota hai, that is more likely. And remember, both of these are non-spontaneous reactions. That is the main takeaway here. Both of these are non-spontaneous reactions, both anode and cathode. But we are making them spontaneous by passing electricity through them. Extremely important. Bar I'm repeating it. That's great, Arman. And it's really good to see your dedication. You can always ping me for physical and organic chem. I teach chem on Discord and Telegram. All right, I'll help you out for sure. All right, class almost khatam ho gayi hai. AK gaming almost done. One last idea to explain and we are done. Okay, theek hai. Now, when you have NaCl solution, things get interesting. Things get interesting. यहाँ तो obvious है कि H2 will come out. Why? Because it's a smaller value. Smaller मतलब, you know, I need to apply an opposite potential of just 0.38 volts to get it done. That's okay. But when you look at the anode, this is interesting. You would think कि भाई oxygen निकलना चाहिए, but oxygen does not come out. Instead, chlorine comes out. So I need to give it an even more voltage, but it doesn't work out. यहाँ देखो कुछ अजीब हुआ है. A smaller value required over here, but still, you know, chlorine comes out and not oxygen. क्यों? Because this concept of over potential. Okay, so kinetically speaking, till now we are talking about thermodynamics. Okay, E naught matlab delta G matlab thermodynamics, but now kinetics come to the picture. Sometimes, yeah, when the potentials are very close to each other, then you need to keep in mind कि देखो, there is a kinetic idea because of which experimentally ये रेट बहुत स्लो होता है ऑक्सीडेशन निकलने का, चलो ऑक्सीजन छोड़ो यार, क्लोरीन ही निकल जाता है, एंड दिस आइडिया इज नोन एज ओवर वोल्टेज और ओवर पोटेंशियल. ओके, टू इंक्रीज इट्स रेट यू नीड टू अप्लाई अ ग्रेटर पोटेंशियल डिफरेंस एंड दैट इज ओवर वोल्टेज ऑफ ऑक्सीजन. ठीक है, बट इसके बजाय सीधे Cl माइनस का हो जाता है. दैट्स इट. विद दैट आई एम डन विद दिस सेशन. इफ यू हैव एनी डाउट्स प्लीज आस्क मी. कोई टेंशन नहीं है, आई एम नॉट इन एनी काइंड ऑफ हरी टू दिस. प्लीज लेट मी नो इफ यू हैव एनी डाउट्स. शीतल, इट्स ओके, कर लें, कुछ खतरनाक नहीं होता है. It's all very doable. It's all very doable. Nidhi, you're amazing, bro. I have no words for how amazing Nidhi is. And Arman and Sheetal, all of you are exceptional people. Sheetal was on the NEET channel as well. Arman is getting every question right so quickly. Lovely. All of you are amazing. All of you are amazing. Yeah. Okay. Lastly, I think I have some homework questions for you. I do. Here is the first homework question. Okay. It'll be great if you try it out and comment mein daliye. If you like this video, please share it with your friends. Yeah. And subscribe to the channel. I know, जो लोग chat करें वो तो है subscribe. People who are watching it later, maybe you're not subscribed. Please subscribe to get amazing content like this. First homework question. Second homework question. ठीक है? I'll meet you again on Tuesday. आज Tuesday है ना? हाँ, आज Tuesday. I'll meet you again on Thursday, and we will wrap up most of electrochemistry. Solutions वाला idea कर लेंगे. और उसके बाद शायद एक और सेशन कर लेंगे जस्ट टू कवर एवरीथिंग, कोल रॉशॉइड एटसेट्रा. विल डू द बेसिक्स ऑफ आयोनिक सॉल्युबिलिटी एंड ऑल दैट, आयोनिक कंडक्टिविटी एंड ऑल ऑफ दैट नेक्स्ट सेशन में ऑन थर्सडे. एंड या, ऑन दिस वीकेंड वी विल स्टार्ट डूइंग पीवाईक्यूज ऑफ इलेक्ट्रोकेमिस्ट्री. नेक्स्ट वीकेंड विल रैप दैट अप, एंड उसके बाद 30th नवंबर को वी स्टार्ट रिवीजन, एज अमन वाज आस्किंग. नॉट अमन, समबडी वाज आस्किंग, आई डोंट नो. ठीक है. शंकर, क्या शाय आ रहा है? Shankar, ping me on IT Chem, bro, if I missed it out. Yeah? Intense session. Ping me here. I'll try and help you out on Telegram or on Discord. All right, folks. That's all I have for you today. Good night and have an awesome Tuesday. I'll see you again on Thursday. Yeah. All right. Bye, Rek, Aman, Nidhi, Shankar. I'm going to try and look up. अरे, अरमान already answer देते हुए, सही है. रुको. शंकर, तेरा सवाल है कहाँ भाई? Faraday first law. Deposit amount of substance on electrode during electrolysis direct proportional to passing of quantity. ये डाउट कहाँ था? ये तो तुमने कुछ स्टेटमेंट बोला. Faraday first law, second law का पढ़ाई हो चुकी है. Okay, that's great. I'm not gonna find your doubt, bro. Ping me, I guess, yeah, on Telegram. चलो, I'll see you guys on Thursday. Thank you so much for attending this session. Do share this with your friends if you liked it and if you found this to be helpful. Bye. Good night.